So first off, so I gave you this worksheet, function operations worksheet number 1. Plan for today, we'll go over a few questions from that. Just I want to clear up a few things. There's some specific problems that as people were turning it in, I just want to make sure that you're understanding a few things before we move on. They're fairly straightforward, so it should be pretty quick, pretty easy to clear up. Then we're going to get into kind of the last lesson of chapter 6 here, where we're going to talk about how you find inverses of functions. We'll get into that. It's actually fairly straightforward. We'll go through a couple of examples, and the other class today had about 10-15 minutes at the end where you had a chance to get some work done and actually get some things taken care of. The function operations worksheet, this one is due. This is the last assignment that is due this quarter, okay? So that assignment is due either today or tomorrow, okay? And just a reminder of that you got to get that in either today or tomorrow. Otherwise, then when I do the grades on Friday, if it's not turned in, I'm going to put in NEs for that final third quarter grade. Okay? So just a reminder on that. If you don't have it in by that assignment is due this quarter, which means today or tomorrow.
Okay.
Okay. All right. So if you take a look, problem number 7. As you take a look at problem number 7, one thing I wanted to just revisit again, because I mentioned it the other day when we talked about the lesson, but some people were making the same mistakes yet on the assignment. So if they give you g of t and f of t, and they're saying here that you're subtracting the two functions, what I want you to think about is this. If we have g of t as 3t plus 1 minus f of t is t squared minus 4t. Remember, when you're subtracting functions, you're subtracting the entire quantity, okay? Some people, when they went through and did this problem, wrote it like this, and therefore, what's the mistake? Yeah. In this case, you're only subtracting the t squared. You're not actually subtracting the entire function. You got to distribute that, okay? So if we did that, that's the only reason I put these in parentheses. So if you distribute, you would have 3t plus 1 minus t squared, and then this becomes a plus 4t. Now you clean it up and just combine like terms, okay? So just a reminder again that when subtracting, I think there's like 3 or 4 of those on the front side. Make sure you distribute that minus sign, distribute that negative. So ultimately, final answer, you'd have negative t squared, 3t and 4t, give you 7t, and then a plus 1 at the end. Okay, so just a quick heads up on that one. Like I said, that's just a clarification more than anything.
It's hot here again.
A little bit.
You should go over number 5.
Number 5, let's take a look.
That one was a little confusing.
We can do that. Let me come back. Since I already have these up there, then I'll come back. So then if we go to the back side, to number 12, a different reason that I wanted to go over number 12. In this case, we're dividing, so 12 and 14, you're dividing the two functions. So if we go through, the dividing part's not very hard because you're just putting one over the other. So in this case, we would have 2x minus 2 over negative 4x minus 3. There's not anything else you can do in that case. There's nothing that's going to cancel. There's no simplifying. However, remember, one of the things we said was when you have a fraction, you have to consider that you got to limit the domain a little bit. Okay, remember there's some values where x cannot equal something. Okay, and if you remember back to the other day, we said the denominator you cannot divide by 0. So the question is, well, what value of x would make the denominator equal to 0? We want to eliminate that value. So easiest way to do it, just take the denominator and set it equal to 0. If I take negative 4x minus 3 and set it equal to 0, now I can figure out what value of x would give me 0 in the denominator. Meaning, add the 3 over, divide both sides by negative 4, and we end up with negative 3/4 as our answer. Okay? Now, that's the value that would make the denominator equal to 0, which we can't have. Therefore, that's the one value of x that we exclude. X is not allowed to equal negative 3/4. Because if it did, we'd get 0 in that denominator, and we can't have that. So that one I wanted to go over because I wanted you to see when it's not super obvious, because some people put down on a couple of problems, said, well, x can't equal whatever it is, 1, 0, whatever it was. But when it gets a little bit messier like this, I wanted you to see the process again. Just take the denominator, set it equal to 0, and figure out what the x value is. Any questions on that? Doing okay there? Okay. Similar idea, if you take a look at number 14. Again, we're dividing. In this case, we have 3x over x squared minus x. In this one, again, what I want you to see is there's a little bit of simplifying we can do here that is a little bit different than some of the other problems that you had. In the denominator, notice I've got an x in both of those terms, which if you think back to factoring, that means I can factor out the greatest common factor. So I could rewrite this as, I could pull an x out of both of those, leaving me with x minus 1 in parentheses then. Okay? You factor out that greatest common factor, the x. That's now kind of in factored form, and now it's a whole lot easier to figure out what x cannot equal. We look at one factor. What's one number that x cannot equal? 1. Remember, we're checking to see if we don't want 0 in our denominator. We can't have 0. Well, if x equals 1, we get 0 for that factor, and therefore 0 for the whole denominator. So x cannot equal 1. What's the second answer? What's the other thing x cannot equal? 0. Because if x equals 0, this would be 0. That would end up being -1. 0 times -1 is 0. So those are the two values that x cannot equal. Okay? And now the only thing left, I actually can simplify this a little bit because those x's cancel, and you're left with a final simplified version of 3 over x minus 1. Okay? So that one I wanted you to see as well. I wanted you to see the factoring out of the x, which is why you've got a couple of values that x can't equal. Okay? Making sense on those? Getting the idea? Those are probably the 3 that I saw as people were starting to turn this in. The idea of what can x not equal on this problem, the factoring part of this one, and then just the reminder that you got to distribute the minus sign on this one. You want to go back to 5, you said? BG? Okay.
Yes.
Let's go back to number 5 then. All right, so there's the problem. Here's your function, f at a, and there's what you're plugging in. So in this case, you're going to take this a plus 2 and substitute it in place of the a in the equation. You're just plugging it in, that's all you're doing. So when I do that, we have 3 times, I take the a out, I put the a plus 2 in its place. Okay, we make a substitution. So we put a plus 2 there, that is still squared. And then we still have the 5 at the end. So the only thing I did was took the a out and substituted in the a plus 2 in its place. The rest of this problem now is just simplify it all down as far as you can. Okay? Which, remember order of operations? We talked about that the other day. As you simplify, don't forget your order of operations. Meaning I need to deal with the exponents first. Okay? How do I square a plus 2?
A plus 2.
Remember, you cannot distribute. You can't just square the a, square the 2, because there's a plus sign in there. Anytime there's addition or subtraction, you can't distribute over that. This is a plus 2 times another a plus 2. So if you did that, we write it out and then we'll actually do it. That's what you actually have. And now you just got to multiply it all out. Okay? When I multiply the a plus 2's, we get a squared plus 4a plus 4. When you multiply these two out, this is what you'll get. And now, last steps. Take the 3. Now multiplication would come before addition. So now we distribute the 3. Get 3a squared plus 12a plus 12, and then you still have the plus 5 at the end, and now we just combine like terms. So that 12 and 5 go together, get you to 17. Making sense, hopefully?
Yeah, I got that.
Oh, it's 20.
So this worksheet for the most part was kind of two main ideas. When you have functions, what kind of operations do we do? Can we go through and add, subtract, multiply, divide? And then the other part is, again, this where we're substituting stuff in, okay? All right, we okay on that? See, if you have more questions, because I'm hoping that we'll have 10 or 15 minutes at the end of the period, I'm hoping that then if you have more individual questions, I can come around and just help you on an individual basis, okay? All right, so let's move into the lesson then, because the lesson's not going to take a real long time. And in this case, I've got the actual lesson here for you.
Wait, and again, this is our last, like, assignment that we have to do.
That was
Right.
one.
This is it, yep. When you get back from spring break, we will start a new chapter. We'll start a fresh start on that one.
Wait, then what are we doing with this lesson?
Teaching it, and you'll have some time to work on it in class. This will probably be, the assignment I give you today will probably be the first assignment that will be due for the fourth quarter. And part of the reason why we're doing this is I'm going to refer to some of the stuff we talked about today in the next chapter. So it's really just kind of setting up the next chapter is what's going on. So if you take a look, the last section of chapter 6 here that we're going to talk about talks about inverse functions, okay? Just like you would normally think, inverses means opposites of each other. And so the objective is to be able to figure out how can I find the inverse of a function. Couple of notes basically down at the bottom, the bottom slide that you have here. One note, remember, f of x, g of x, h of x, all these different things we've talked about, they all just mean y. Okay? There's just a different way of writing y equals. Okay? So just a reminder on that. Second thing, I put the steps right away because this is going to be the main idea. In order to find the inverse of an equation, it's basically a two-step process. Sometimes it's a fairly easy two-step process. Other times it gets a little bit more complicated. Okay? As the functions get more difficult, the process gets more difficult. But step number one is you switch the x and the y. And step number two, you then resolve the equation for y. Okay? So if you think about these as inverses, you're inverting x and y. You're switching them. Okay? And then resolve your equation. So if you take a look down below there where it says inverse relation then, well, that means if you got x, y, when you flip it, then it becomes y, x. Okay? Any point, like if I had the point, for example, 2, 3 on the original function, I know that the point 3, 2 then would be on the inverse. If I had the point 5, 10 on the original, that means 10, 5 would be on the inverse. Okay, so a little bit of a relation there. If both the relation and the inverse are functions, then it's not just called an inverse relation, it's then called an inverse function. That's more just a kind of a heads up on that. Okay, so if we take a look, go to the next page then. And the top slide on the next page. So if we're taking x and y and we're flipping them, what that means then is the domain of the original function, okay, the x's, are actually becoming the range of the inverse. And the range of the original is becoming the domain of the inverse. Okay, let me kind of graphically show you what I'm talking about. If we talk about like parabolas for a second, okay? If I were to sketch this out, let's say that this is my parabola that I have here. One thing you did that we're not going to get into it a ton this year just because of trying to save time and cutting out some of the not as important stuff. But one of the properties of an inverse is that when you graph it, if you remember back to geometry, it was way back, it was actually the very first chapter. At the time, you had no idea that you were doing this. But if you remember back to geometry and you talked about translations and rotations and reflections and all that kind of stuff, you might remember that at some points you were reflecting things diagonally over the line y equals x, if you remember that. That's exactly how a function and an inverse are related to each other. So if I were to go through and draw this line in, let's say that's my line y equals x, that 45-degree line. Well, in this case, if I then take this and reflect it, this would actually reflect, well, look something like that. Okay. This would be your original function. When you reflect it, it turns and it kind of turns on its side and it becomes a sideways parabola rather than a vertical one. Okay. So that, just a heads up on that. So here's what I'm getting at when I say domain and range. So domain of any quadratic is always all real numbers. You can square anything you want, okay? Well, if you take a look at the range of our inverse is all real numbers. This is going to keep going up. Even though it looks like it's flattening out, this is going to keep increasing forever. This is going to keep decreasing. So the range of this function matches the domain of this one. If you look at the range of the first function, it's from 0, y is greater than or equal to 0. We'll look at the domain of this one. X is greater than or equal to 0. Okay? So again, that's what I'm talking about when I talk about how the domain and the range switch. If I ask you to find the domain and range of a function, when you then look at the inverse, they basically just flip-flop. Okay? So just kind of a quick heads up on that one. Let's take a look at example number 1 here then. I got a couple examples. The main focus for this year is going to be, here's the equation. How do I find the inverse equation then? What's the process? And this is the part where it's hopefully isn't too bad. So take a look at that first example that I gave you.
Just figure, I don't know if I can do this, my hand hurts.
Okay.
From writing so much today.
It's not my class.
I don't know if I can write with my left hand.
You try your best. So first off, quick notation thing. This notation is not actually the function raised to the -1 power, kind of like we talked about in the last chapter. This is just the notation of an inverse, okay? So f to the -1 power of x is just, that's how you write the inverse of f of x. So, quick refresher again, f of x really just means y, so this equation is y equals x squared minus 1. And now I'm going to follow those 2 steps that I gave you right away. Step number 1 is actually flip the x and the y. Okay, let's invert them, again, if you think about it that way. So this becomes x equals y squared minus 1. And now we resolve that equation for y. I've got to get y back by itself again. So what's step number 1? How do I get y by itself?
Some one on the other side.
Yep. Get the term by itself first, so we got to get that with the 1 over here. So we get x plus 1 equal to y squared. And now we take the square root of both sides to unsquare the problem, which means y equals the square root of x plus 1. Now, just a quick heads up, again, going back. What do we always have to have when we take the square root of both sides of an equation? We did this back when we were solving radical equations.
Numbers.
Nope. When you take the square root, you always have how many answers? Plus or minus. There's a plus or minus in front of that. And I'll show you why it matters in just a second. This is your inverse of this original function. And like I said, I'll kind of show you graphically. You're not going to have to graph it, but I want you to at least see it so it makes sense to you. Quick question. Are you surprised that since your original function was a quadratic, an x squared, that the inverse is a square root? I say I'm hoping that you're not real surprised by that, because square roots and squareds are inverse operations of each other. So that should be, I'm hoping that makes some sense. Okay? Graphically, here's what this would look like, by the way. And again, you're not going to have to graph this. I just want you to understand it. X squared minus 1, if I graph that, that is a parabola. It gets shifted down 1. That would look something like that. The square root function, the reason why we need the plus or the minus, if I don't have that, a square root only looks something like, let's see, it would look something like, that would be the positive square root. The reason I need the plus or minus, it gives you the bottom half of that parabola. Okay? Without the plus or minus, you only get half of a sideways parabola. The plus or minus gives you both parts. So again, if I took this and I reflected it, that's why a vertical one now reflects into a horizontal one.
Well, that's what X and Y does?
That's what, when we switch the X and the Y,
Okay.
that's what happens.
Okay.
Okay? Now, your main focus is going to be on finding the equation, but I wanted you to just kind of understand why you need the plus or the minus. If you didn't have the plus or minus, you would only have half of a sideways parabola.
So what if it's cubed?
So what if it's cubed? Okay, I'll give you an idea. So if you had a cubic function, what do you think the inverse is going to look like equation-wise?
Plus, plus, minus.
No. What I mean by that is, what's the inverse operation of something cubed?
X cubed.
Square.
Cubed root.
Oh, cubed.
Okay, so your equation would end up being a cubed root. If you think about, like, if you're talking graphically, the idea would look something like this. Let's say you had, let's say you had this, and then it would look something like that. What it turns out is you would end up, it would be kind of going left and right instead of up and down. That's the difference. You're not, and again, you don't have to, I'm not gonna make you graph it, I'm not gonna worry about that, but that's kind of what, to answer your question, what it would look like. It would take this equation that is generally increasing, and it would flip it, and then it would kind of be horizontal rather than vertical. All right, let's go to example number 2.
So the answer is Y equals 1 times square root.
That was your inverse equation for that problem.
Oh.
So example number 2, we now have f of x is the square root of x plus 2, and I want to find the inverse function. Let me ask you a question before you start. What do you think the equation of the inverse is going to end up looking like before you even do anything?
Square root of X.
If we're starting with a square root, what's the inverse of a square root?
Oh.
Squaring. So we're going to more than likely end up, our answer is going to end up being an equation that's got an x squared in it. Okay? Because squaring is the opposite of taking the square root. Okay? So just a heads up. So let's actually do the process then. If this is y equals the square root of x plus 2, flip the x and the y. So it becomes x equals the square root of y plus 2. And now we resolve this for y. So what's step number 1? How do I get y by itself? You're right.
The 2 away. Well, you can square it 2.
Opposite of square, we got to get rid of the square root first. So to get rid of that square root, we square both sides, which means this becomes x squared. The square root then goes away, and you're left with y plus 2. So we square both sides to get rid of the radical. Notice, there's the x squared we were talking about. And now what's the only step that's left?
You square root it now.
Nope.
Well, you move the 2.
Remember, we're just solving for y. Get that plus 2 over to the other side. So I end up with x squared minus 2 equals y. And there is your inverse equation for that. Remember, like we said, you started with the square root, ended up with an x squared as the inverse. And that's kind of the main idea there. Let's take a look at one more example here. Let's look at this last one.
Is it example number 3?
Yep. All right, so if our original function is 4x plus 6, negative 4x plus 6, we want to find the inverse equation, the inverse function. Out of curiosity, just a quick question, and I don't even really care all that much whether you're right on this one or not. I just want to see where you're at. We said we started with a square root, ended up with an x squared. Example 1, we started with a squared, ended up with a square root. Any idea? What do you think we're going to end up with on this one? What do you think?
No.
Squared? Fraction? Okay. What? By the way, what shape is that if I were to graph it? What? I just here. That's a line. Yep. That's linear. We got this is in y equals mx plus b form. So that's a line. And so let's take a look. Let's see what you come up with here. So if we write this as y equals negative 4x plus 6. Flip the x and the y. So now we've got negative 4y plus 6. And resolve. Get y by itself. So I'm going to subtract the 6 over. And then get y by itself, divide everything by negative 4. And I'm going to rewrite this just a little bit. Because I don't really like leaving it like this. I want to be in a form that's a little bit more you're used to, a little bit better. So think about this. Remember, this is like a 1x right here. Well, 1 divided by negative 4, that's a negative 1/4 x. If I just write that in fraction form. And then if I take negative 6 and divide it by negative 4, we can reduce that. First of all, it's positive. 6/4 is 3/2. There's your inverse equation.
Oh my gosh, I turned it on for a second.
What's the shape? What did I end up with?
What are you complaining about now?
It ends up, started linear and ended up linear in this case. If you were to graph this, here's generally what this would kind of look like. This would be something like that would be your original function. And it turns out, like if this was your line that we were reflecting it over, you would have, kind of turns out that it would be something like that. It's kind of the inverse function, it's roughly. But it basically just reflects, so the inverse of a linear function is still a linear function. Okay? Otherwise, like Si had asked before, if it was cubed, the inverse is going to be a cubed root. If it was to the 4th power, the inverse is going to be the 4th root. Okay? That's kind of why we're ending up in this spot. All right. So the last thing I have for you, if you do not yet have the other worksheet done, the one that we started off by going over questions. We've got about 20, 25 minutes here of class time. If you don't have that done, that should be your number one goal, is get that done. Okay? If you have it done, I'm going to give you this next worksheet, and basically it's just a combination of what we did the other day and then the stuff we just talked about. Okay? As again, answer keys are out on Canvas. Please make sure you're checking your answers. Let me go through and give you the worksheet, and the rest of the time is yours to be able to work.